Okay, let's do the same for the thighs of the character. And as you can see, one of the things I've done to my scene so far is I just changed the display of our twist joints to little planes. And that's going to be less intrusive for the visibility of our rig. And also it's going to help us later on to have a visual differentiation between these joints and the actual deformation joints, which will be shaped as spheres. So let's use these planes for now. And let's continue with the thighs. So we're going to use exactly the same rig that we used for the shins of the character, except this one is actually going to be running downwards. And the idea is because over here, the control or the reference for the twist of the lower leg is the foot. So as the foot rotates, this twist rig is going to work. But here our twist point is more going to be at the hip. So as the character twists its leg, rotates it down the x-axis, this is going to be like our reference twist point. So in this case, we need to start from here and work our way downwards. So let's get to it. I'm going to create a locator, and we're going to set this locator's drop action to parent, because we're going to parent it directly to our existing thigh bone. So let's drop him here, and we're going to call him locator left thigh twist start. Okay. All right. So we're going to duplicate it, and we're going to name the duplicate thigh twist end, and we're going to parent it to our start locator. And the idea is we're just doing that to get a distance reading as we did before, because later on everything is just going to be parented directly to the thigh bone. So we're going to set our drop action to match position, and we're going to drag and drop this end locator over to the shin bone, the calf bone, so that we actually move him down to that position, but we are maintaining the orientation that it has relative to its parent. And that way we should only see a change in the X position channel. Okay, so now we have a position reading, and what we're going to do is duplicate this locator 3 times, so we get 3 cross sections like we did down there. So let's do that 1, 2, 3, and we're going to call them not end, but segment 1, segment 2, and lastly segment 3. And we're going to parent them one to another, 3 to 2, 2 to 1, so that again we can use our distance reading in a much easier way. So let's take segment 1, which is right now parented to the start, which is great. And we're just going to take the X value and divide it by 4. So he's going to move up here. Okay, we're going to copy this, just Control C to copy the value, and paste it over to segment 2, and then paste it over to segment 3. So now we have evenly spaced locators. Okay, now what we're going to do, since we're right at this, is change their display attributes. So let's take all the segment locators and the start. We're not going to take the end locator yet, which seems to be selected. Let me see if that's the case. What do we got here? Oh, no, he was not. 3, 2, 1, and the start. There we go. And we're going to change their display attributes to make them planes, just like the ones in the bottom. So let's change this to plane, replace. They're going to be looking down on the x-axis, and now we're just going to resize him. more or less something that size. Okay, and while you're at it, you can also change their drawing colors. So we're going to do the same sort of orangey color that we've done for the others. And now we're going to take the nth one and we're going to make this one into a cube. So it's going to be the same box. Let's just change its size, and we're going to make him bigger so that we don't get confused with the one for the shin, which is the small one. And same thing, let's give him some nice orange color like that. Alright, so now we have the locators in place. Now all we're going to do is take all of them and shift select our thigh bone and say parent in place. So now they are all a single flat hierarchy of children under the thigh bone. Now we can start rigging this. Before we do so, remember that we're using an up vector for our lookat constraint. So let's create the locator for that. So I'm just going to create a locator and set my drop action to match. And I'm going to drag and drop him again onto the thigh bone so he comes over here. And now using local move mode, I'm going to move him to the side. So remember, you have to be on local, otherwise you're going to see some flipping when you assign this as an up vector. We're going to make him smaller. And let's call him up vector left thigh twist. Okay, great. So now we can take our start locator over here, and we're going to take the end locator over there, and let's turn off compensation and do a direction constraint. So right now our friend here is going to flip. So let's take a look at the properties for the direction constraint. So the first thing is we need the constraint on the x-axis, and it has to be the negative axis because everything on this side of the character is with x pointing up. And now we're going to change the up vector from the y-axis to the z-axis. Okay, so right now our object here is still misaligned because he has the z-axis pointing towards the right when it should be the y-axis pointing towards the right and the z-axis pointing backwards. But I'm gonna just shift click on my up locator over here to assign the up vector and click on assign up vector, and as you can see now y is pointing to the right and z is pointing backwards, so we're good. So now that we have this done, as you can see, if I grab my FK control, which is controlling the leg right now, and I rotate it, we get no twisting at the start of our leg. Okay, so that's great. Let's now start our constraints for the intermediate segments. So these guys, remember, we have to constrain them in rotation using the thigh bone and our start locator as the targets for the constraint. So we're going to do that. We're going to select our locator, and we're going to shift select the thigh and shift select the start locator and say rotation. Okay, so this one's done. Now we select our next friend, shift select the previous locator we already constrained and the start and say rotation, and lastly this guy with him and our first start locator and constraining rotation. So let's see what we have. Let's select again the FK control and twist, and as you can see we have the twisting happening right there. So that's great. And again, we can rig the weights to have different values being biased down the thigh, if that is what you would like. So if we would like to do that, all we have to do is come back to the schematic and go to the legs rig workspace, and let's see what we have. Here we have the rig that we created for the bias on the shin, remember? So we can do the same thing, but for our friend here, which is this locator, the thigh twist. So let's see, where are the thighs of the character? Over here. Yeah, they're gonna be around here somewhere. Here's the thigh. Alright, so this is the right side. Let's go back to the left side and let's add our control. And here we have the constraint for the thigh, the rotation constraint. And remember, since these guys, the segment 1 and 2, are depending on this guy's rotation values, and we don't have to worry too much about rigging those manually. So we just need to rig this one. So we're going to do the same thing as we did for our calf. We're going to use a value that we're going to create ourselves, and then inverse that and rig it to the appropriate weights over here. So let's create our two math nodes. Where's math? Add. So we have here one add. We're gonna duplicate that and set the second one to subtract, and this one is going to be 1 minus whatever comes in from the add. For the add one, I'm gonna rename it to UTI, utility node left thigh twist bias. Oh, bias. There you go. And let's set this guy. Let's see what weights we have in the over here. Here we have 100%, and here we have 100%. So we need to right now they're weighted 50-50. So we need to change those to whatever we wish over here. So to get started with a 50-50 weight as we had it, I'm just gonna set this to 0.5, and then as we rotate this in the viewport, we can start to tweak a value here that we like more. So let's say this guy goes to the thigh and this guy goes to the start. So let's take our thigh and rotate it outwards like so. So as you can see, in my opinion, this is not rotating enough. It's rotating too much towards the neutral rotation or no rotation. I want him to rotate a little bit more so he can actually follow the knee a lot better. So let's change our math node and let's start increasing that until we can probably set it to 0.85. That looks much better. Even 0.9 maybe. If you prefer, you can go all the way to 1 so that you perfectly follow the where the knee is pointing to. But I'm gonna leave it at 0.9 just because I know I'm also gonna have a little bit of compensation down here in the shin. But that pretty much gets our rig done for the thigh of the character. Let's try it out as we pose the thigh in different positions. As you can see, it's holding up pretty well. So looks like we're done with this guy. Let's return the thigh to its neutral position. And the last thing to do is we need to know what to do with our locator over here. So this guy, our thigh twist up vector, I'm going to parent it to the hip joint. And we haven't finished rigging the hip yet, but we're going to do that later on. So for now, I'm going to parent it to that with compensation on to do a parent in place, and it's done. Now, I just need to do the opposite side of the character. So as you know, it's exactly the same procedure. I'm going to pause the video right here, and I'm going to come back when this is done to show you how it went. So I'll be back in a second. Okay, so I'm done rigging the other leg, and as you can see, everything is working fine. We have the up vector, we have everything I've rigged over here, the weight values, so everything is okay. The one thing to be aware of is that when I assign the up vector, if I go here to our start locator and we check out the direction constraints parameters, the axes were flipped because it was expecting the up vector to be on the other side of the character. So all I did to get my axes aligned back the correct way was introduce a 180-degree offset on the x-axis. So that way I was able to get my y-axis pointing in the right direction, which is towards this side. Otherwise, you're going to end up with this guy being flipped relative to the other locators we've created. And when you start doing your constraints, you're going to see a lot of really bad, funny and not funny way behaviors. So just be aware of that you will need to introduce offsets to keep your axes aligned properly as you continue to work on the rig. But other than that, the rest is fine. I also set my bias weight to 0.9, so I get a lot more twisting down here, down the thigh, pointing towards the knee. Otherwise, at 50-50, it doesn't really look very well. And that's it. That's all we need to do to get our thigh twisting correctly. All I have left actually is to take this guy and also parent it to the hip bone. So let's turn back on compensation and just parent in place. And that should do it. We're done with the thighs of the character. So now we can proceed to do the arms of the character as well, and then we'll be ready to take care of our actual deformation system for this particular character. So let's keep going. Okay, we're ready to do the arms. So what we're gonna do is do the exact same rig on the arms of our character, except one thing we might change is for the purpose of this exercise, if we go and check our geometry, because these joints are shorter, we might use, instead of 3 segments, we're just going to use 2. This is something that is highly dependent on the mesh topology that you have to work with, and also with the kind of movements that the character has to perform. And characters that are more elastic, so to speak, you'll probably need a higher number of segments to be able to achieve the deformations that are needed. But for the purpose of this training exercise, we're just going to leave it at 2. In any case, you already know how to add more if you need to. So let's take care of this arm for our character very quickly. So let's start by creating a locator, and I'm going to match it to our forearm joint, and we're going to duplicate it, take the duplicate, make it a child of the original, and we're going to set its drop action to match position. Let's drag and drop it onto our hand joint. So we have here the spacing offset that we're going to use to space our locator. So let's duplicate this guy twice, and let's parent them like so. Okay, so now I can take the first one, divide this by 3, and copy that value and paste it onto the second one. So now we have our evenly spaced locators. Let's select these three and make them into nice little planes. And let's make them smaller. Yeah, I think that is enough. Let's take the last one and we're going to leave him as a box. Let's also make him smaller. And let's take everything and color them with our now traditional orange color. There we go. Now we can start renaming them. So this is our locator left forearm twist end, and let's copy that and let's make this guy start, and then he is going to be segment 1 and he is going to be segment 2. And now we take everything and select our forearm joint and parent in place. There we go. Let's go find them. There they are. All right, now we can create the up vector that we're going to use for the direction constraint. Let's set the drop action to match, and let's drag and drop him onto this locator, and let's move him backwards in local space. Let's leave him there for now, and let's see how things work. So the first thing to note is the orientation of our segment joints or locators. So we can see the x-axis is pointing upwards and the z-axis is pointing forward and the y-axis is pointing inwards. So let's take our start and the end and do our direction constraint. Let's go to the direction constraints properties, x-axis pointing upwards, that's fine. Let's make z the up vector, that's good. And let's now shift select our locator back here and assign the up vector. Let's see where we're at. In this case, y should be pointing down and z should be pointing towards this other direction. So let's reselect the direction constraint, and we have to rotate our constraint 90 degrees. In this case it's minus 90. So we have z pointing now towards the up vector, which is what we wanted, but the up vector is in the wrong location. It needs to be at the front of the character then. So let's move him to the front, like so. So now we have the proper z pointing forward, y pointing inwards. Let's check with this. Yeah, that's exactly what we want. So we got to be careful that everything is sharing exactly the same orientation, because if not, you know, when we do our rotation constraints, things are going to be behaving really bad. So let's just make this guy smaller. And let's rename him since we are already there. Up vector left forearm twist. And we're going to parent him to our chest joint over there. Compensation on, parent in place. All right. So now actually, sorry about that. I'm thinking about something else. This guy needs to be parented to our hand joint, because the hand is the one that's going to be doing the rotation. So, oops, this guy to the hand joint. Okay, there we go. All right, that's better. So let's check out that that actually works. Let's rotate this. Yeah, our up vector is rotating properly. Okay. So now we need to constrain these guys in the same fashion that we constrained the ones for our leg, which if you need to check, let's see, we were going to select the one closest to the where the up vector is parented. Let's find them here in the items list. Right click and select input items. So you can see that this guy is constrained in between our start and the next segment over here, which means that is the one at the top, this one, the first one, that gets constrained to the joint and the start. So we're going to do the same thing over here. We're going to select this friend, and he's going to be constrained to the joint and our start locator. Okay, and we add compensation off, a rotation constraint, and then him is going to be constrained in between the previous locator and the start one. So now if we take a look at how things are going, we have everything working nicely. And again, we can change the bias on this later on if we expose it to the schematic view. So let's proceed with the upper arm. I'm going to create another locator, and we're going to align it to our upper arm joint. Duplicate, parent to duplicate, and match it in position to the forearm joint. There's our offset distance. Duplicate twice, parent these guys like so. So take that one, divide by 3. There we go. Copy the value and paste it onto the last one. Perfect. So now we take these 3 locators, make them into planes like so, and then take the last one and make it into a box, slightly bigger one than the one for the forearm. Now we can proceed to rename stuff. Locator left upper arm twist, and actually I should copy that first, and let's take this guy, segment 2, this guy, segment 1, and this guy, start. Now we take everybody, shift select the joint, and parent them in place. Okay, and now to do the constraints again, we can once more, if you need to, refer to how it was done for the thigh. So if we select our friend here and check its inputs, we will see that he's constrained between the next locator and the start one. So we need to start with this guy over here closest to the knee. So he is going to be constrained to the joint and the start locator. So let's do that. We're going to select our friend here. Before I do that, of course, we need our up vector locator. So I'm gonna match it over here. Oops, needs to be match in every transform. There we go. And for now, I'm gonna move him forward and check later if that's the correct position for him. So again, him, constraint to this guy, and the start guy over here, compensation off, constraint and rotation, and then this guy between him and him, also rotation. All right, so let's check how this is going. The joint is not rotating, which probably means we are using the IK arm. So let's go to our schematic. Yeah, the IK weights are on. So let's turn them off. So we can check our arms using the FK arm. Let's see now. Okay. Everything is working properly so far, except we haven't done the direction constraint. So let's take our start and then our end, and let's do direction. And right now everything goes out of whack because I had already constrained those friends. We're gonna have to fix that. So this in this case is x-axis, but negative, and then we have to set the up vector to the z-axis. And now we select our locator over here and assign the up vector. And let's see what we have in terms of orientation. So Z should be pointing forward, X up, Y inwards. And with him, we need another offset. So is this minus 90? Yeah, there we go. Perfect. These guys realign themselves properly. And I forgot to give them our color that we use to make them easier to read. There we go. So now that that's done, let's try again. That's great. And it looks like the weighting is going to work just nicely for the purpose of these two parts of the character. Still, you can expose the weighting to the schematic if you want. So we can do that right here in the clavicles workspace. So it's, I believe, him. Let's check the inputs again. Yes, it's him and him that we need to bring into the schematic. There we go. So there's the upper arm and here's the lower arm. You can reorder this if you want to make it a little bit more sensible in terms of laying this out in a more logical way. So what we need to do is add a math node. Let's duplicate that. We're going to need one for down here. Duplicate that again. And let's set this guy to subtract 1 minus something and duplicate that and bring this guy here. So this guy, he's going to be UTI left upper arm twist bias, and this guy is going to be UTI left lower arm twist bias. Okay, and we're going to set them to 0.5 just to get the same weighting we currently have in the scene, and then we just wire everything properly, and we're done. So that's how you do the arm of the character. As you can see, it was exactly the same as we did before. Let's take care of this locator. This one, we haven't renamed it, so let's rename him really quick. Up vector left upper arm twist. And this is the one that is going to be parented to our chest bone. So let's do a parent in place, and let's just make him smaller. Okay. So we're done with the left side of our character. Since the right side is just basically a repetition of what we've done, I'm going to pause the video right here and come back as soon as I'm done with this side, so we can just check out how things look for both sides of the character. So see you in a second. Okay, we're done. As you can see, both sides of the character are done. We have both sides also exposed in the schematic view and already weighted. Everything still to 0.5, which was the default when we created the constraints. We're gonna see if we need to tweak that value later on after we have skinned the character, after the mesh has been attached to the hierarchy we're going to use to deform it, so that we can have a better visual reference for the amount of deformation going on in those areas. So for now, we're going to leave it at that, and we're going to continue working on our deformation system in the next video. So let's keep going. Okay, we're ready to create the twist rig for the neck, and this is exactly what we've done for the others. So it's going to be pretty straightforward, except we're not going to use as many twist joints. We're actually just going to use 2. That should be more than enough. So let's do this. We're going to start with creating a locator, and we're going to match it to the neck joint. And this is going to be our locator center neck twist end locator. So let's change it into a box. Like so. Okay, and I'm gonna parent it to our neck joint. So let's go to turn on compensation, parent in place, and there he is. All right, so now let's duplicate it, and we're going to rename the duplicate to twist start. Oops, last character. Okay, and we're going to match it only in position to the head joint, so the orientation remains the same. And we're going to change its display attributes to a plane oriented on the x-axis. Okay, and let's duplicate this guy one more time, and this is actually going to be our up vector neck twist, and we're going to move it locally somewhere in front of the rig. And this guy, let's remove the special shape options. We're just gonna make him smaller. And we're gonna parent it over to the head control. Okay. So we have everything set to create the look at constraint, but before we do so, let's also create the twist segments. So we're going to create 2 of them. This one is going to be called, oops, don't delete the entire name, segment 1 and segment 2. So let's take segment 1 and its position x, we're going to divide it by 3. We're going to take that value, copy it, go to segment 2 and paste it, multiplied by 2. There we go. Alright. So that's good. Now we can do our constraint. And actually, before doing so, I'm going to take all of our locators we just created, and let's make them orange, just as we've done with the others. There we go. And now we can take our first the twist start and then the twist end and do our direction constraint. And of course right now everything goes crazy. We need to go to the constraint, change the axis to the x-axis, negative in this case because the original orientation was looking up. And let's change our up vector to the z-axis, and now as you can see the orientation should be the same on everybody. Okay, now let's take our start twist object item and shift select the up vector. Let's go to the direction constraint and assign that as our up vector. So now when I grab our head control and rotate it, the twist is already working for our end object, and I can take the neck and rotate that, and the rig seems to be holding up. Alright, so all that's left is to constrain our segment twist joints or twist locators. So we're going to select the first one, and then we're going to select the neck joint. Looks like something else is selected. Let's make sure nothing is. Let's try that again. This guy, the neck joint, and our twist start, because he's the one that needs to twist the most following the movement of the head. And let's do a rotation constraint. And now we're going to take our second locator, the neck joint, and our segment 2, and do a rotation constraint. And let's take a look. There we go. So everything seems to be working fine. Okay, so everything's ready. Our neck rig is done. So now that we have all the twisting for all of our limbs, we can move on to start looking at the formations for the entire character. So let's keep going.